Question 10-0, square roots. Essential question. How do you solve an equation with a square root in it? Alright, the first thing I want you to do is name the first 10 perfect squares. I'm going to give you a minute or two because I want you to be able to do this from memory. You should be able to do this without me doing it on the smartboard immediately because you've done it in some of the previous lessons. I'll get you started by just writing the numbers 1 through 10. But this needs to be a list that you can create on your own because it's not something that you'll be given on the MCAs. It's something you would need to create on your own if you needed it on the MCAs. So go ahead and start writing the first 10 perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. So hold on to that list for the next slide. Alright, these are not perfect squares. Find the integers that they lie between. So again, like I said, you're going to want to use your last list to help you with this. So the two perfect squares that fall on both sides of 70 are 64 and 81. So that means the integers that lie between, that the square root of 70 lie between, are 8 and 9. The negative square root of 55 falls between the negative square root of 49 and the negative square root of 64, which is negative 7 and negative 8. Square root of 41 falls between the square root of 36 and the square root of 49, which is 6 and 7. The negative square root of 23 falls between 16 and 25, which is negative 4 and negative 5. Square root of 38 falls between 36 and 49, which is 6 and 7. And the negative square root of 18 falls between 16 and 25, which is negative 4 and negative 5. Now we're going to get into some new equations. Now there's going to be parts of these equations that are familiar to you and parts that you haven't seen before. The new parts are going to be the square roots and the squared signs. So on each problem we're going to do a little something different. So it'd be good to make sure you're closely writing down how to do all these problems because they'll really help you on your packet and on Study Island. On this problem, the first thing I want to get rid of is that square root sign. So you have to ask yourself, how do you undo a square root? Well, if you think about it, if you're adding and you want to do the opposite, it's subtracting. If you want to subtract, the opposite is adding. Multiplying and dividing, dividing and multiplying. The opposite of square roots is squaring. The opposite of squaring is square root. So we're going to square both sides. So that gets rid of my square root. The square root and the square cancel. So I'm left with x plus 4. And then 13 squared is 169. Now I'm back to just a basic one-step equation. All I have to do is subtract 4 on both sides. And I'm left with x equals 165. The next one is 4x squared equals 32. On this one, I need to get rid of that 4 first. So the way I'm going to do that is this is like my couple, 4x squared, divide both sides by 4. So I'm left with x squared equals 32 over 4. And then to get rid of something that's squared, I take the square root. Now here's the thing about taking the square root of something. Something squared, whether it's positive or negative, always ends up positive. So for example, if I have 2 squared, I'd end up with 4. If I have negative 2 squared, I also end up with 4. So that means that this answer can be positive or negative, 32 over 4. That's a new concept that we haven't really talked about yet. But the positive square root of 32 over 4 or the negative square root of 32 over 4 would both be solutions to this. All right, 2 square root x equals 17. This is like 2 times the square root of x. So let's get rid of that 2. Opposite of timesing is dividing. So then I'm left with the square root of x equals 17 over 2. I'm just going to leave that as a fraction because it didn't divide nicely. To undo a square root, I have to square. So 17 squared is 289. And 2 squared is 4. So that is my answer, 289 over 4. If it divided nicely, then you could leave it as a whole number, but it doesn't. It's 72.25. So we'll just leave it as a fraction. All right, this one looks a lot more complicated than it is. 15x squared plus pi is equal to 8x squared plus 5 pi. I am solving for x. So I'm going to circle my x's, and I happen to have one on both sides. So my first step is to get the variable on the same side. So I could either subtract 15x squared on both sides or subtract 8x squared. I'm going to subtract 8x squared to keep everything positive. So 15 minus 8 gives me 7. Bring down the pi. And bring down the 5 pi. Now 7x squared is my couple, meaning my third wheel is this pi. So I'm going to subtract pi on both sides to get rid of my third wheel. So I have 7x squared equals 4 pi, because if I have 5 pi's minus 1 pi is 4 pi. Let's continue breaking up my couple, so divide both sides by 7. I'm left with x squared equals 4 pi over 7. Now, like I said before, if I want to undo something that's squared, I have to take the square root. But remember, square root, I can have both a positive and a negative because of the what I explained earlier. So my answer is 4 pi over 7, but it's either positive or negative. So there's actually 2 answers, positive or negative. And the last one. So this one, I want to get rid of that squared first because that parentheses around my whole problem. So let's take the square root of both sides. The square root and the square root cancel, so I'm left with x plus 3 on this side, and then the square root of 20 on this side. To get x alone, let's minus 3 on both sides. So I have x equals, and then remember I took the square root of that 20, so it could be plus or minus the square root of 20 minus 3. Now people always think that it should be the square root of 17 because 20 minus 3 is 17. But if you take the square root of 20, so if I took my calculator and found the square root of 20, and then I subtracted 3, I'd get 1.4721, a decimal that keeps going forever. If I took the square root of 17, I get 4.1231, keeps going forever. So I don't get the same answer. So you've got to keep that square root of 20, the square root of 20, and then you can subtract 3 on the end. So tag that on to the end. Summary. The homework for this lesson is a packet.